I've got question number 55 up on the board. This is one of your assigned homework problems. So in a moment, I'm going to suggest that you pause the video and try and work it out. Before I do that, I'm going to give you a hint. If you don't want the hint, pause the video now and try it on your own. If you do want the hint, I would suggest that you start with this side and use the difference and the sum formulas for cosine to simplify this. When you do, you'll have the left-hand side in terms of sines and cosines. So then I'm going to suggest the three-paragraph method. Then switch over to the right-hand side. Right now this is written in terms of cotangents. I would suggest that you write it in terms of sines and cosines. It's going to give you a messy complex fraction, but if you simplify the complex fraction, you should be able to prove that the two sides are equal. Okay, so I would use the sum and difference formulas here, rewrite things in terms of sines and cosines, and then simplify the complex fraction here. And don't forget, if you are using that three-paragraph method, don't forget that third paragraph to then say, oh, look, they simplified to the same thing, so they're equal. Okay, so if you've been listening this far, pause the video now and give that a shot. So I'm going to follow my own hint. I'm going to use the three-paragraph method. So here's my left-hand side. Here's my right-hand side. On the left-hand side, I'm just going to write out the sum and difference formulas. So the left-hand side was cosine of alpha minus beta. These are just Greek letters. Over cosine of alpha plus beta. And that's going to be. So with cosine, the cosines go together in there first and then the sines. With the sum formula, it's a minus sign. So with the difference formula, it's a plus sign. So cosine alpha, cosine beta, plus sine alpha, sine beta, over cosine alpha, cosine beta, minus sine alpha, sine beta. Looks like the top and bottom have a lot in common, but of course nothing cancels because we can't cancel across addition and subtraction. So that's my first paragraph. I've simplified the left-hand side. Now I'm going to switch to talking about the right-hand side. So notice, because I'm doing a formal proof, anytime I was saying things were equal, I did write that equal sign. Now when I'm switching to the right-hand side, I'm not connecting it with an equal sign to this, which is the left-hand side. Okay, so the right-hand side was cotangent of alpha, cotangent of beta, plus 1 over cotangent of alpha, cotangent of beta, minus 1. And I'm just going to write this in terms of sines and cosines. So that's going to create a lovely mess. That's going to be a complex fraction. But cotangent is just cosine over sine. So this is cosine of alpha, cosine of beta over sine of alpha, sine of beta. Cosine alpha over sine alpha, that's my cotangent alpha. I'm sorry, this should be cotangent of beta is cosine of beta over sine of beta. Plus 1 over, same thing, but minus 1. So cosine of alpha, cosine of beta over sine of alpha, sine of beta. Those two pieces give me the cotangent of alpha. Those two factors give me the cotangent of beta, and then minus 1. Now, that's this lovely complex fraction. How do we simplify complex fractions? We multiply by 1. And we multiply by 1 in the form of whatever we want to cancel over itself. What I want to cancel is the product of these two signs, because those are the internal denominators in this complex fraction. So I'm going to multiply by 1 in the form of sine alpha, sine beta. Now, of course, I've got to distribute that to each piece on top and to each piece on bottom. When I do that, I so want a larger board. Okay, I'm going to have to just come up here to keep going. When I do that, when I distribute to this first term, it cancels those denominators. So I'll have cosine alpha, cosine beta. And then I'm multiplying that by 1. So plus sine alpha, sine beta. Over. On bottom, when I distribute, again, I cancel out that denominator. So I've just got cosine alpha, cosine beta. And then I'm multiplying it by the minus 1. So minus sine alpha sine beta. Ah, that's what the left-hand side simplified to. So don't forget this last step. The left-hand side equals the right-hand side. That's really important because if you just stop and somebody's reading your work, they might be like, why did you stop? Were you lost? Were you tired? Or were you done? This says I stopped because I was done. So you're not leaving it to the person reading your proof to figure that out and say, wait, is that what we got last time? You're saying, that is what we got last time. You're doing the work of saying, hey, I did my job. Okay. So this was an interesting one, I think, because it started out, it looked pretty intimidating. But I said, well, I see sums and differences, so I want to use a sum and difference formula. And I knew that was going to get things in terms of sines and cosines, and that's sort of my go-to if I don't know what else to do. So I got things in terms of sines and cosines and simplified my complex fraction, and we were done. So it wasn't clear to me, I'll be honest, it wasn't clear to me. I sort of had a sense that this is what I wanted to do. It wasn't clear to me that it was going to fall out quite as nicely as it did. You're not always going to see, you're almost never going to see the entire proof of an identity. If you approach identity saying, there's something wrong with me because I don't see why those two sides are equal, there's nothing wrong with you. I look at identity, I say, oh, I think those are probably equal because the book's asking me to prove that they are. Other than that, it's not obvious to me that they're equal. But I can see things that I can do to simplify, and I just say, I could do this, I could do this, I could do this. I just walk along and then I say, now it's obvious that they're equal. But it's almost never obvious from the beginning. So there's nothing wrong with you if you look at an identity and say, I don't know why those are equal. What you need to be able to do is say, I can see a way that I could simplify one of those sides. If you see something you can do, that's all you need.